Good morning, students. Today we are going to study electromagnetic induction. The phenomena of electromagnetic induction can be demonstrated by an experiment. Wind an insulated copper wire on a paper or a wooden cylinder so as to form a coil in the form of solenoid. Connect the two ends of the coil to a galvanometer and place a magnet close to it. The reading of the galvanometer is 0 when the magnet is stationary. The pointer of the galvanometer deflects towards the right when the north pole of the magnet is moved towards the solenoid. The galvanometer shows 0 reading when the motion of the magnet stops. This proves that as long as the magnet keeps moving, the current flows in the solenoid. If the magnet is moved away from the solenoid, current flows in the opposite direction. Thus, the galvanometer deflects towards the left direction. The deflection increases if the magnet is moved away with greater velocity. If the polarity of the magnet is reversed and the magnet is brought close to the solenoid, then current flows in the opposite direction. The galvanometer accordingly turns towards the left. Here, Faraday observed that current flows in the coil only when there is a relative motion between the coil and the magnet, and the direction of deflection gets reversed if the direction of motion is reversed. Now there are various factors which lead to the increased current in the coil. The first factor is if we use a strong magnet, the current can be increased. If the motion of the magnet is increased, then the current can be increased, and if the number of turns in the coil increases. So according to Faraday, when there is no relative motion between the magnet and the coil, the magnetic flux within the coil remains constant, and thus the galvanometer shows no deflection. But when the magnet is moved towards the coil, or if it is moved away from the coil, the magnetic flux changes and an EMF, that is electromotive force, is induced in the coil. Now, the direction of induced EMF depends on whether there is an increase or decrease in the magnetic flux. And to find the direction of induced current, Fleming gave a rule that is known as Fleming's right hand rule. According to Fleming's right hand rule, if the thumb, forefinger and the middle finger are placed mutually perpendicular to each other, and thumb will represent the direction of motion of conductor, forefinger represents the direction of magnetic field, at that time the middle finger will represent the direction of induced current.